All
All
right.
right.
Now, what I was going to do originally was sizing cable trays because I hadn't seen anybody really go in depth on that. But
No.
we've had a little bit of a disagreement here the last 2 days, and I want to give a big shout out to the great Jeremy Weed. Uh, he's been arguing with me left and right over this, and I told him just for him I would give him a shout out on here, and I was going to go through and
Nice.
cover the electrodes and the grounding electrode conductors to a point, but I want to show some of the information that was voted on by the code making panel and their substantiation, and go from there to show why table 250.66, which used to be table 250 94, and had exceptions underneath it. Now it's A, B, and C. I want to go through and explain that as its relationship to the table itself after I go through all the electrodes. Okay.
Well, and I want to do a big shout out to Stall Cup Senior because me and Junior had never even heard any of the stuff before he covered it on the last one. So you can go back. We'll try to maybe get a little clip of that one when we do our little shorts that we're going to come up with. We're going to get a bunch of clips of all our episodes. And that was really amazing. That was a great presentation he did. So,
Yeah, that was really amazing because he explained how the table was developed and
mhm.
the testing and everything they did and the multiplier 1.189 that they used in order to determine the sizing for the grounding electrode conductors in the table. I mean, it was really, I had never heard that before, but you
Well,
know
yeah,
that.
and you think about you have on 250 102C, you have an overcurrent device, and then they related that multiplier to that
Yeah,
percentage of that overcurrent device, even though in service entrance you don't have a line side overcurrent device.
that's right. It
So
was amazing listening to it
yeah,
and how they did it, and guess what? It works.
yeah.
So
Dude, I tell you what, like I wouldn't think of an inspector that would allow us to install a Yooper ground anything smaller than number 4. So,
no, and I'm going to prove that tonight. All
all
right,
right,
so let's get
sounds
started.
good.
Okay, now what you're going to see, these are going to be some of the new illustrations. I'll give you a sneak peek that you're going to see that'll be coming out in the new design book. And these are going to be in our online course. These are very, very detailed in our colored wires and everything. I mean, they fantastic job. But when you start all this, you go to 250.50, and this is where you pick up grounding electrode system. And basically, it says all the electrodes that are there, they say in 250.52A1 through 7 that are present in each building or structure served have to be what? Bonded together to form the grounding electrode system. That's all I'm going to do right there. We know you have to do that. So here's our illustration. You'll see we give loops to tie all of this in too, so you don't you get an idea of what you're looking at. But if you're looking at uh, number one, we show there a concrete encased electrode. You need a number four. We show you the sections there and looking at 250.66B to tie in with 250.52A3. You got your structural steel. We're telling you here that the service is being supplied with 600 kc mill. You go to table 250.66, you're going to need a 1-aught. If I go and look at 250.66A, it's going to tell you a driven rod needs at least a number 6. If I go to metal water pipe, you use the table, it's a 1-aught again. And if I go to a ground ring, 250.52A4 and 66C tell you it needs to be a number 2. Okay. And if
Right.
I go to a plate electrode, it needs to be a number 6 per 250.53H and 250.52A7. That right there gives you just an encompass of everything we're about to look at. Okay.
So, question for you, kind of a stupid question, I guess. So, lately I've been noticing some of these commercial buildings, we've been running a Yooper ground and 2 ground rods. And so I just didn't really understand because I know back in the day when we first started it's always changed. It seems like with the engineering, and
Mm-hmm.
it seemed like what they had back in the day was we either had to have two ground rods or a Uper ground, and now we have both. Is that because we have to use all and available means?
Well, if they tell you they want a you for ground, they're probably uh, wanting to have a better ground at the service. I think the let me ask this: are you bonding in also as an electrode the cold water pipe coming in?
Yes, sir.
Okay, that more than likely what the engineers look at. I've noticed this over time. They think they have to supplement that, and so they
Okay.
do a supplemental over there, and they think, oh, I'm supplementing for that cold water pipe, which is required. And then when you go over and look at 250.68C1 to tie that in, and then some of them look at it and say, well, I'm probably not getting 25 ohms or less, so I need to move over at least 6 foot and drive another rod. But
Right. Yeah,
I,
I get that part, but I mean, I know at one point we could run a Uper ground and not even use any ground rods.
you can do that. You
Oh,
can
so
do that.
that's like a IEEE or something standard or
There's no
that.
standard. That's just engineering what they want you to do. You know,
Okay.
and they're probably looking at it and saying, well, we got a concrete encased electrode here we can use. Let's go ahead and get that. And then they probably went and you had a pretty good sized pipe coming in for your cold water pipe, used it as an electrode. And I think they probably thought they had to supplement that also.
I gotcha. And the thing that I was gonna add to that, the one thing I've noticed as this trend is almost every drawing when you go into the engineering, it's showing like a 2-aught or a 3-aught going to Uper ground. It's showing a 2-aught or 3-aught going to the ground rod,
That's
and
wrong.
and so that's the thing that I've noticed as this trend. And I've seen guys do some weird stuff. I actually have pictures I posted in the groups where one of our foremen out there went and took 3-aught to a ground rod with a rebar clamp. So you're actually voiding the listing that's not listed to clamp to a ground rod. It's listed to clamp to rebar. So you're actually voiding the listing of that, equipment. And you're thinking that you're doing something great by running 3-aught to it, but you don't have a solid way to attach it, which I would say the only real true way to attach it would be CAD weld.
Yeah, but even CAD weld, you get a conductor that's too large to a smaller conductor, it can break loose. And that
Yep,
was one of
I
the
agree.
things that Dad did on the one podcast that he was talking about that. And that's why they limited it to go up to a number 4 to a concrete encased electrode,
Right.
was for those reasons. And that's one
I
reason I
agree.
like doing all these podcasts and going over these things because a lot of people don't know this information and why the co-making panel did what they did. And
Yeah,
uh,
and I didn't know it either because what they were saying is like if you're bringing a 3-aught, let's just say in your illustration there to that concrete encased electrode, and you're trying to CAD weld it, what's going to happen is you're going to get a kind of almost like an air bubble in the
that's
middle
right.
of that, and then that's not going to make as good of a contact as possibly say a number 4 solid with a good listed clamp or identified clamp or you know
Sure.
listed, labeled, or identified clamp that's for that
Yeah, and I
situation.
think Dad did a great job explaining all that. And he goes through it and explains why they did all the testing and tried all these different size conductors and what they needed for each type of electrode. So,
Yeah, and then just another question too. I'm not trying to take up the
yeah.
whole. I'm not trying to steal your thunder here. Like if so, let's just say you have a building steel there.
Hmm.
Let's just say that this building that you're at has a whole bunch of those I beams that are just like say embedded in cinder block and possibly just maybe just some I beams that support weight. Are those required to be bonded to the building?
They're required to be bonded by 250.104. That's not that's bonded in, but it's not a grounding electrode.
Oh, gotcha.
It's
So you're not
bonding
using
within.
it.
Right.
So if those steel beams are connected to building steel and building steel is your electrode, then they are bonded, right?
Correct.
Okay,
Right.
I got you.
And we're about to look at that here in just a second.
Okay, 10-4.
Okay. So, and then you had your other type of local metal underground system or structures. You could have an underground tank, metal well casings, plate electrodes. These also will serve as electrodes also. So these are all the ones that are listed in 250.52A1 through A8. Okay.
Okay.
Oh, and
So it's kind of like that same thing. Like if you have like a gas pipe, you can bond that gas pipe to your electrode system, but you're not using it as an electrode.
right. And
Gotcha.
one of the things that you'll notice in all of our publications, you won't see this in the others. You'll see like we have loops that are there. We're taking you through all these loops and everything, where you look at it not only for the sizing and the installation, but it tells you how to go through that loop in order to make sure you're doing the proper installation. And basically, we're setting you up as you get into the installation part. Okay.
Gotcha.
Now, the next
Yeah,
one here,
it's gonna be great to have access to that. So I'm excited.
right. Now, when you look at a metal underground water pipe as an electrode, it has to be in direct contact with earth for at least what, 10 or foot more. Okay. This, and I'm showing you the text, so you don't have to believe me. I'm just showing you straight up. This is what it says. Okay. Now, if you come over and look at that illustration, you'll notice we're showing here to help tie this in. Here's the metal water pipe on the right hand side, 10 foot or more in length right here. Okay.
Yeah.
And then we tell you, if you go over and look at 250.68 C1, it has to be connected within what? 5 foot of where it enters the building. And then you'll notice right on the left hand side, we're saying since you're using a metal water pipe, as an example, what you brought up a while ago, we're telling you per 250.53D2, it has to be what? Supplemented. And
Yeah.
then we tell you to look at 250.66A, and you need at least a number 6 going to that. Okay.
Right.
And then if I look at this and I've got 250 KC mil conductors, and I look at table 250.66, the grounding electrode going over to the cold water pipe needs to be at least a number 2. Now, I am going to point one thing out, and I might do another class to show this and or another podcast. But when you get in, you start looking at that metal water pipe. That we actually have a chart that's in our publication. I hadn't seen it in any others, but we actually go in and show you based on the Copper Pipe Association. They tell you based on the size of that metal water pipe, you want it to be a certain size based on the conductor connecting to it. So you take a number 2 here. That I can tell you by looking at their chart, they don't recommend connecting that to a 1/2 inch metal water pipe coming in. You see what I'm saying?
Right. And
So
that's typically not the size of a main coming in anyway. Typically, I don't think they go really smaller than a 3/4 most of the times. But like I say, I don't know.
even then, I think the 3/4 too small. I'll have to go
Okay.
back and look
Yeah.
how that chart's at, but I have that information. We'll do that.
No, we could actually run that as a myth too. But one thing I wanted to point out, and it could be something that might work good in your illustration, is to add any kind of, like a lot of times what we run into in this case, we run into like a water meter, or we run into like different kinds of things that are in line with
We have that.
connection.
We have that.
And so that's just something everyone's going to have to remember, that you have to jumper that to maintain that continuity, so that if that device is ever changed, then you're maintaining that continuity around that connection point.
Sure, we show it where it's coming in, and we show where you have a water softening device, and then jumping across that. Yeah, we show that in one of our other illustrations.
It's something. That one's going to be a myth too that I'm going to run, because a lot of guys don't think you have to do it.
Yeah, you do.
You're bonded, but yeah, you don't want to kill plumbers over something like that.
Yeah, we got the information to do that.
Okay.
Okay, then you get into your metal in ground support structures, like you were just talking about, and it tells you it has to be in direct contact with earth vertically for at least what 10 foot or more, with or without concrete encasement. Okay, and then it tells you if multiple in ground support structures are present at a building structure, it shall be permissible to bond only one into what the grounding electrode system. And
Ah.
that's what I was telling you. You get in here, you
Okay.
start reading this, it ties the rest of it in. Okay.
I got
Now,
it.
as you look here, we're showing where you have your beams and stuff coming up. And then we show one that is in direct contact with earth for 10 foot or more. And that's when it's considered uh, a grounding electrode. Okay.
Gotcha. Okay.
Now, when I get to the concrete encased electrode, it gives you an option here, and it says it shall consist of at least 20 foot of either one or two. So you can have one or more bare zinc galvanized or electrically conductive coated steel reinforcing bars or rods of not less than a half-inch diameter installed in one continuous 20-foot length, or multiple pieces together where you're using steel tie wires, exothermic welding, or other effective means to create 20 foot or more, or you can have a bare copper conductor that's not smaller than number 4 within the footing there. Okay.
Gotcha.
And then it goes in and tells you that the metallic components and everything shall be encased in not less than 2 inches of concrete and shall be located horizontally within that portion of the concrete foundation or footing. Of course, that's in
Gotcha.
direct contact with the earth. So then you got to get in and look at the informational note. And it says concrete installed with insulation, vapor barriers, films, and similar items separating the concrete from the earth is not considered to be in direct contact.
I agree.
Okay?
I agree with that.
All right.
And this was interesting. That one was interesting too. When Pops brought it up, that basically all those they were originally in the code called made electrodes,
Yep.
which was ground rods, UPers, and ground rings, and they were actually referred to as high resistance.
Mm-hmm.
And so, but they decided to remove the term made electrodes and then just put them all in their own separate section so that it just made it less confusing for everyone.
Right. And we show you a few things like at the very top of this illustration, we're telling you it's okay to extend that up from the footing of that concrete there, and you can use a reinforcing rod or you can use number 4 copper conductor for this. Okay.
Right.
And then we show you, you can see where we have the beam going up. Now, if I take and got 20 foot or more in there, then that automatically not only is the concrete encased electrode, I could come off of that and turn it up. That bonds the beam in as an electrode also. Or I can just go to the beams and I've got the concrete encased electrode that's causing that to be bonded in. Or I can take and just run a number 4 down in the footing, turn it up and make a connection to that. Or I could turn up a rebar and make a connection to that. So what we did in this illustration is give you a lot of different things to look at. Because if I go back here and you look at this, it says it only has to be what 10 foot or more in direct contact with earth. But if I come over here and I've got all this tied in as a concrete encased electrode, which specifies it's an electrode, and bonded in, tied into this beam that's going up here, then all of a sudden, guess what? That becomes what? An electrode.
Yes,
See what
sir.
I'm saying? So
yeah, it's kind of the same concept a little bit. We actually did a myth about basically light pole bases, and it's not even really required by the code. So some of our myths we're gonna like get out there and produce them and get them kind of out there to where you guys can just see what the myths were and we might even have to do a show where we just go through all the myths and you
Sure.
know.
Well, that's why it's good to show all these because, I always tell everybody just go compare illustrations. And, like this illustration here, this is a good example. We're showing you a lot of options in that illustration,
Yeah.
things that you can look at that you need to think of. Most of them don't show you all of this and show you all the different sections you need to go look at to make the determinations of what you're going to do. So if I'm looking at it from an installation point and turning it up, 250.68C3 is giving me that permission. Okay.
Right. And the thing that's nice about this is when you subscribe, once we get the whole LMS up and running, you'll have access to all these illustrations and you'll be able to pull them up right on the job site and show people.
Yeah. And one of the good things is, say I have a chapter just on grounding and bonding, unless it's something that I'm using for tracking purposes, like I was doing licensing or you're prepping for a journeyman or master exam, those are time limit. But everything else you purchase, unless I have it on a time limit somehow, that course is yours from now on once you purchase it.
Yeah,
So
I will give everyone a disclaimer. Like if you purchase the 24-hour from Colorado, you might get gypped on a few code changes. But James made sure he gave me his honor that he was gonna make it up. So once I get all squared up on those code changes, I'll let everyone know. I'll make sure I do an announcement, and we'll be all square on 2020 code changes.
sure. Now, I do want to point something out here, and this is something for testing purposes. Say you're doing a concrete encased electrode or ground ring. You can take and you've got a conductor in the ground. You'll notice it's always what? 20 foot. You
Yeah.
see that? And this is telling you if you got 20 foot or more bare conductor, not smaller number two, that will make up in direct contact with earth part of your ground ring that's encircling the building or structure. Now,
Yeah.
usually when I look at a ground ring, I know it says 20 foot or more, but if I'm putting a ground ring in, it's going all the way around the building. That's
Yeah.
just
I
me.
mean, I was gonna say that's a pretty small building to be 20 foot.
Yeah, no kidding. And here's just a good illustration. It tells you if you go over and look at 250.53F, it tells you it has to be at least 30 inches deep. And then I need a number two going over there and then circling the building of at least 20 foot. And that is based on 250.52A4 and 250.66C. So you can look at all of that illustration there and see we're giving you the sections to tie that in so you get all the installation and everything. Now we take it a little more in depth when we get a little further into the electrodes, but this is sort of prepping you for what you're about to see.
Right.
Okay. Now, when I look at rod and pipe electrodes, it tells you it should not be less than 8 foot in length, shall consist of the following materials, and tells you the sizes and everything. So if I'm taking using steel, it says it shall have a surface galvanized or otherwise metal coated for corrosion protection. It has to be at least 3/4. If I go in and I'm using one that's stainless steel and copper or zinc coated steel, it has to be at least 5/8 of an inch in diameter unless it's listed. Okay. So here's your requirements looking at this. And then if I go look at 250.66A, it says that conductor going over has to be at least what? A number 6. Okay. So that helps tie everything in as far as sizing what is required for my electrodes. Okay. And what is considered an electrode. Now, from that point, I want to point something out here. Now, when you go look at 250.66, it says size of alternating current grounding electrode conductor. And what it says is this: the size of the grounding electrode conductor at the service at each building or structure where supplied by a feeder or feeders or branch circuit or branch circuits, or at a separately derived system of a grounded or ungrounded AC system. So I don't care if it's even grounded or ungrounded. It says shall not be less than given in table 25066. Now look at this. except as permitted in 250.66A through C. Now, you've heard me say this when this argument came up. I said, anything that's not listed in A through C, you use the table. What's listed here, these are the sizes that are given. Now, I'll tell you where the argument comes in. If I look at A, we'll just do A because you're going to see the exact same language in here. But it says, if the grounding electrode conductor or bonding jumper connected to a single or multiple rod, pipe, or plate electrodes, or any combination thereof, as described in 250.52A5 or A7, does not extend onto the other types of electrodes that require a larger size conductor. It says the grounding electrode conductor shall not be required to be larger than number 6 copper. Okay, so what they try to tell you, it says shall not be required to be larger. And they're saying, since it says shall not be required to be larger, then that means you can drop down. No, it doesn't. What it's saying there is they do not want it to be larger than number 6 because of connection purposes. Okay. And the same thing in B. And I'm going to prove this to you because the language hasn't changed. Now, watch this. If I come over and look at the table, and just like we did a while ago, we said we had 250 KC mill coming in, and I'm going to cold water pipe or building steel, and I'm going to copper. I'm using copper conductors. It tells you it needs to be a number 2, right? Okay. Now watch this. When I come in and I look at 250-94, I want you to see the language. Okay. And these were exceptions at the time. And this is where it said we're connected to made electrodes. Okay. Now they don't say made electrodes anymore. That's what you brought up earlier. And it says that portion of the grounding electrode conductor, which is the sole connection to the grounding electrode, shall not be required. Look there. Shall not be required to be larger than what? Number 6. If I go to a cold water pipe, shall not be required to be larger than what? A number 4. Okay. Now, people would say, oh, well, based on that, the way that language sort of reads, I have the option to go down. No, you don't, because I'm going to show you right here. This was a substantiation that come in when they started making these changes. And this is from the 1984 edition. And this was submitted by Ernest E. Cannon, that was in Tempe, Arizona. And he comes in and he explains this. Now, I want you to pay attention. It says, in the revisions of the NEC 1975 for the NEC 1978, concrete encased electrodes were relocated from section 250.83A to section 250.81C, and the rebar was added. Section 250.94, exceptions 1 and 2, then changed from all these sections. And it says, it appears that the concrete encased electrode, or UFER electrode, was recognized as meeting the criteria for the exception during the 1975 NEC, but lost that recognition in the 1978 and remained so in 1981. Data submitted by Proposal 61 for 1974 preprint indicates that the expected resistance of the UFER is such that number 6 would be more than adequate as the grounding electrode for the concrete encased electrode. Perhaps it was an oversight that the concrete encased electrode was relocated without being relisted for the exception. In general, data indicates that the resistance of rods or plates may be expected to be less than that of the concrete encased grounding electrode. The panel rejected this unanimously, and they said proposal would permit concrete encased electrodes to be connected with a number 6 copper conductor, which is considered to be what? Too small. In summary, the panel unanimously was affirmative that a number 6 for the concrete encased electrode would be considered too small. Now, I can't be any more specific in that. They're telling you that you have to connect to that concrete encased electrode with at least what? A number 4. And for these people that come in and say, well, that's not what the code says. I don't care what you think the code says. This is submitted documentation that was voted on by the code making panel and specifically stating that that conductor cannot be smaller than a number 4. You have to connect a number 4. If I go to a ground rod, it has to be what? A number 6. Okay. And I think that right there sort of explains how the grounding electrode conductor has to be sized and why we do not use the table and why they say except as permitted in what? 250.66A through C, because their intent was that that conductor is a size that going over there that is allowed for the electrode in the first place. So can't hear you, Bill. Can't hear you. Can't hear you. You went blank.
I must have muted myself. Anyway, no, that is the soul connection, though. You know, so like I think that's the big language that everyone needs a key on. It is the soul connection to that electrode. So that's where they said. So you could combine electrodes. You can take a Uper ground and tie it to building steel. And then you could take building steel with a 1-aught down to your service, and you're fine. The thing, what the language of the code was saying, it cannot be the soul connection. So that's where everyone gets confused on this, because they're like, well, table says if I have this service entrance conductor, then I can have this to the concrete encased electrode. You can't have your cake and eat it too. You can't just say, hey, this gives me permission to do something that A through C doesn't give me permission to do.
Well, I always look at it this way. If you're unsure about something sometimes, always go back and look at the substantiations from the code making panel. And if the code making panel says that you know, shout out to you, Jeremy. Jeremy says, oh, that's your opinion. And then I show him what they say, and he doesn't want to hear. He says that's not what the NEC says. And you know, my whole point is, I don't care at that point what your opinion is. The opinion doesn't matter. The opinion that matters is what come from the code making panel and their substantiation, because they're the ones that reviewed all the testing data and everything to make that decision. You didn't make that decision. And you didn't review any documentation. And for you just to go off and just start saying, well, that's not right. And then he cites to me what it says in the source book, which is wrong. And I say, you can cite whatever sources you want, or somebody that's on co-making panel 5 now that he apparently knows, and tell me that's not what they say. Well, I don't really care, because I'm showing you what the code-making panel said. And that language hasn't changed to this day. And for anyone to say that I don't care what that says, that I got a problem with that, because you're basically saying all the testing data, everything they did to make their decision doesn't matter. I just don't understand that. I really don't.
Well, I thought it was really funny because I've been constantly attacked and bombarded by people, and I'm happy about it. I love getting destroyed by people that know the code. I try to respond honorably when I'm wrong, when I'm proven wrong. And I remember when I was doing the myth, when we did that episode with your dad, and I was like, man, are you saying the source book is wrong? And you're all, yeah, that's what I'm saying. And I was like, oh, man. I was like, man, I'm going to just get destroyed over this one, you know?
It is wrong.
Yeah, and I really have faced a lot of heat. There's certain YouTube people out there that's done like podcasts on, you know, that they did ask some question about it, and it was all hypothetical. Like if you have a number 4 service entrance, like, yeah, I've been doing electrical 27 years. I've never seen a number 4 service entrance. I'm sure my bosses would have loved if we could have a number 4 service entrance, but ain't no inspector gonna pass a number 4 service entrance conductor. But you know, even with the 87%. But there's rules in the code where you can have little loopholes. You can say, well, this is a residential install, so we could go off, I believe it's 31014, the allowance where you could use the 87% or 80. But the whole thing is, like, a lot of people disagree with that table for residential. Like, that's the reason you're able to use a 2-watt for a 200 amp service in residential. And a lot of people don't agree with it. But even if you go off a 2-watt, still number 4 to your concrete encased electric, it doesn't change anything by your service entrance.
I'm gonna give an example of something. We got a lot of new people out there, and they're coming on some of these groups and posting videos, supposedly to be experts on NEC and giving these opinions when they don't know what the hell they're talking about. I'm gonna give you one. This one we brought up just a few weeks or maybe 2 months ago, but I'm gonna give an example, and I'm gonna call his name out. Ron Jackson. He basically said that if I come from the panel board and I go over to a disconnect and feed one motor, that's a feeder. I'm gonna tell you right now, that's a bunch of crap. He doesn't
Oh
know
no,
what,
it's if it's a fused disconnect versus a non-fused disconnect.
it doesn't matter
I know.
because and he's trying to give his interpretation. Then he has, when I call him out on it and tell him, that ain't right. I mean, he sends my dad a text complaining, saying, "Is this going to be the stalk up legacy? Y'all don't know what a feeder is." And I was like, let me explain something. If you go look at 430.24 and 430.62a, like we did in that podcast, it literally says feeder, and it says 2 or more, not a single. And this is where a lot of stuff is coming out these days, and there's a lot of false information that is going out on the internet, and a lot of people are believing this stuff. And we get a lot of messages from y'all guys, and we do appreciate it because y'all let us know something that's being said that you don't agree with, and we call it out on this podcast. And I don't care if it upsets anybody, because I believe the code needs to be taught right, and I'm not saying
I'll tell
I'm
you
not.
right now. I'm sorry to interrupt. I'll tell you right now, we're gonna get. I know we were supposed to do the one about if the code was gonna turn into 40 chapters. I'll tell you right now, that ain't happening. But we are gonna do research on that and figure out, because that's a pile of
I just don't
malarkey.
believe that's going to happen. I mean, it could, like I said,
Yeah.
but I just don't believe it. But
I don't see any jurisdiction adopting the 2026 if that happens. I mean,
it's like I said, NFPA better take a long, hard look at that, because there'll be a lot of states not going to be happy, and a lot of facilities, government or facilities, government agencies and stuff that do all these reference to different code document section stuff, and you go change every bit of that, that's going to cause it's going to cause some problems. I'm telling you, because I go to these facilities. I do a lot of work for the Department of Energy, Defense, all different type of government agencies. I go to a lot of huge facilities, and I see their safety documents and stuff that they have, and engineering standards. You take, like, we wrote the inspection report for the pipeline up in Alaska, and then the pipelines here in the States, and we wrote this, and it was all based on National Electrical Code. Now you're going to change every one of those sections because y'all just want to change the code? There's going to be a lot of people upset if they try to do that. I'm just telling you.
and one of the people that's upset is Mr. G. Juan Gonzalez, and I don't blame you, Juan. Big shout out to Juan. He's always a regular here, and hope you're doing all right tonight, Juan. But I agree with Juan that what is the reason? What is driving that change? Like, I mean, yeah, that's fine. I actually saw a lot of pushback with moving all the definitions to Article 100. looking back on it, I kind of think it was maybe a good thing to try to get some double definitions out of there where two exact words meant two different things in the code. And that is not practicable. So, I remember, and that's like kind of a joke, but I remember when they changed the code from everything in the code said practical is not practical to not practicable.
Mm-hmm.
And I never really understood that change. Like, what was the reason? Like, where would somebody be like, hey, that's not practical or that's not practicable? But I mean, to me, that's like the stupidest change. Like in all the codes, I might actually run it in a myth just to throw people off. So you guys better be on your toes. But I mean, to me, I've always said that. Like I never understood that change. Like that was literally in one of my code change classes. Is everything that said practical before says practicable now?
Yep.
Why? What is the difference? Like what? Who cares? Like, I mean, and that's kind of why me and James are doing this a lot too, bringing these myths up, so we could actually go in depth, go in the code, and actually see why they changed it. What was the reason? Honestly, I heard a lot of these myths get told to me by people out in the field, out in the trade. I hear them on the groups, everything, and that's why I come up with them. And I actually heard that this is what I heard as the myth of the week this week, is that the builders were getting tired of electrical inspectors stopping them on construction projects because the building's not dried in. So they added it to dry location, and then
it's never changed.
yeah, and to me, it's a myth. That's where the myths come from. You just hear all this stuff. So we go in there, we bust it down, we bust down the walls and tear open the code. And I mean, we tore this one. And I remember I was sitting there talking to you, James, and I mean, let's go to the 2020, let's go to the 2017, let's go to the 2014. And I'm like, what? Wait, you said it wasn't in the 14. And then he's like, oh no, that was damp location. And big shout out to all the people out there. Damp location is actually moist location. But
well, and that's why I said we were talking about it. I couldn't remember it ever changing, and I was like, I gotta look this up. And then I'd already gone back to 1999. I just said, you know what, I'm gonna have to research this because I just don't even remember the change. Period. And I got a pretty good memory, remembering back to things that because I always write the code change book, and I pretty much remember most of it, and you have to look all that stuff up, and I just could not remember where that change took place. And sure enough,
we were
not
fishing.
I
think we were fishing for a minute.
It was actually put in the code before I was born. Let's put it that way.
Wow. Yeah, that's true. Yeah, so just as a baseline for everybody, we only go back as far as James was born, and then that's like that was like before Christ, and that was before basically what I'm gonna do is I'm gonna pin you in and get you in the whole ballpark with Senior, and then you're like, oh man, I should have never done that, But
I think that was put in during the dinosaur age.
Yeah, see, there you go. You know what I mean? Be like, yeah, it was before James was born, so we're not even going to research
That's
it.
during the Flintstone code.
Yeah, exactly. No, I really want to do a question, like a quiz at the end of the show. So we might try that next week and see how it works. And
okay.
I might try to test you with some code trivia and see how you do. And then just a shout out to all the people that watch the show. Really appreciate you guys all joining us every week. You can join in and put your answers in, and we'll probably have like a little bit of a leaderboard or something, but who gets it right and everything like that. But I'm going to try to do that next week, and we'll see how it goes and see if we continue. But you'll be tuning in at 7:00 every Thursday, so you can try to win the contest. And James, he gets them all right on his second answer. So
Well, especially when it comes with the Cowboys.
Yeah, that was so fun. That was so fun.